Hello, Accelerated Chemistry students. This is Mr. Spurk, and this is your Chapter 12, Section 3 notes, all over limiting reagents and percent yield. So, if we were going to make tacos, you need enough meat, cheese, lettuce, tomatoes, sour cream, salsa, and seasonings, if that's all the things that you like. But if you only have 2 taco shells, the quantity of taco shells will limit the number of tacos you can make. Think about it. If we have a lot of extra meat and extra cheese, but we only have 2 taco shells, we're only going to be able to make 2 tacos. So the taco shells, would be our limiting reagent. So a balanced chemical equation is like a chemist's recipe. Here we have 1 molecule of N2 plus 3H2 yields 2 NH3 molecules. So what would happen if 2 molecules of N2 reacted with 3 molecules of H2? Before the reaction takes place, N2 and H2 are present in a 2 to 3 mole ratio, and we know that from our balanced equation. And as the reaction takes place, 1 mole of N2 reacts with 3 moles of H2 to produce 2 molecules of NH3. All the H2 has now been used up, and the reaction stops. 1 mole of unreacted N2 is left in addition to the 2 molecules of NH3 that have been produced by the reaction. So N2 is left over. We would say that that's our excess reactant. And our reaction stopped because we ran out of H2. H2 was our limiting reagent. In this reaction, only the hydrogen is completely used up. H2 is the limiting reagent, or the reactant that determines the amount of product that can be formed by a reaction. The reactant that is not completely used up in a reaction is called the excess reagent. In this example, nitrogen is the excess reagent because some nitrogen remains unreacted. So we can determine the limiting reagent in a reaction. So if we have copper reacting with sulfur to form copper 1 sulfide, according to the following balanced equation, so we have 2 moles of copper plus 1 mole of sulfur yields 1 mole of copper 1 sulfide. So a typical question for us is going to look like this. It's going to say, what is the limiting reagent when 80.0 grams of copper reacts with 25.0 grams of sulfur? And then the second part of the question is going to say, what is the maximum number of grams of copper 1 sulfide that can be formed when 80.0 grams of copper reacts with 25.0 grams of sulfur? So remember, think about it this way. We have 80 grams of copper and we have 25 grams of sulfur. We're going to add those two things together, but one of them is going to run out first, which will limit our reaction. Now, just because there's only 25 grams of sulfur does not mean that sulfur is our limiting reactant. So let's go ahead and give this one a shot. We're going to be able to solve these using stoichiometry, but we're just going to do them a little differently than how we have been doing them. So there's our balanced equation at the top. So what we have here, our first step is to start with one of the reactants. And you can start with either one, whichever you choose first. Since copper comes first in our equation, that's where I'm going to start. And what we're trying to do is figure out how much product we will produce. So, since we have 80 grams of copper, we're going to use stoichiometry to predict how much copper 1 sulfide we're going to get at the end. And this is the same stoichiometry that we've done, just working from one compound to another. So our next step, we need to cancel out that gram, so we're going to use the molar mass. So 1 mole of copper is 63.55 grams. That's just copper's molar mass. And now we need to switch to the Cu2s, so we use our mole to mole ratio. if we look at our balanced equation, we have 2 moles of copper for every 1 mole of Cu2S. So now our unit that we're working with is moles of Cu2S, and we want to get to grams of Cu2S. Because remember, that second part of the equation said how many grams of copper 1 sulfide can be, what is the maximum number of grams of copper 1 sulfide that could be formed. So let's take this to grams. So we're going to use the molar mass of copper 1 sulfide, which is 159.16, and that's always per 1 mole. So now we can go back through and check our work. All of our units are canceling out the way we want them to, so we must have set this up correctly. And we punch this into our calculator. Remember, we want 3 sig figs because of the 80.0. So we're going to get 100, and make sure you have that decimal point there. So what this tells us is that when we use up all of 80 grams of copper, we will produce 100 grams of copper 1 sulfide. So now we need to do the same thing, but we're going to start with our other reactant. We're going to start with that 25 grams of sulfur. And we're working towards the same product. So same thing here. We go for the molar mass. Use that mole to mole ratio. And here we have 1 mole of S for every 1 mole of Cu2S. And then we're going to use that molar mass, which we've already calculated, so we don't even have to add that up again. Make sure we check our work. All of our units are canceling out the way we want them to. We're left with the correct unit. And we multiply this through, and we get 124 grams of copper 1 sulfide. So let's think about this. If we use up all of our copper, which is one of our reactants, we only get 100 grams of copper 1 sulfide. And when we use up all of our sulfur, we get 124 grams of copper sulfide. So which one of these do you think is the limiting reactant? Which one of these produces less? It's going to be the 100 grams of copper sulfide is less than 124 grams. So copper is our limiting reactant or reagent, which means that sulfur is our excess reagent, because copper produced less. And we also answered the second part of that question all in these 2 simple math steps. It asks us what's the maximum number of grams of copper 1 sulfide that could be produced, and we found that out. It's 100 grams. So we were able, with these 2 quick stoichiometry equations, to figure out that copper is the limiting reagent, sulfur is the excess reagent, and that we only produce 100 grams of copper 1 sulfide. So let's try one more. So rust forms when iron, oxygen, and water react. And one chemical equation for the formation of rust is 2Fe plus O2 plus H2O yields 2FeOH2. So here we have 7 grams of iron to start and 9 grams of water. And it just says, what is the limiting reactant? So it's not asking us to go to grams of the product or to the moles of the product. So we can just take a shortcut, and let's just go to the moles. So we're going to start this the same way as we did the last one. We're starting with 7 grams of iron, and we need to get to moles. The molar mass of iron is 55.85 grams. per 1 mole. And now our mole to mole ratio of iron to iron 2 hydroxide. So 2 moles of iron for every 2 moles of FeOH2. Take a look back at our units. Grams of Fe, grams of Fe. Everything's canceling out, and we're left at moles of iron 2 hydroxide. And so that produces 0.13 moles of FeOH2. So now we're going to do the same thing again, but now we're starting with water because we need to figure out which one of these reactants is our limiting reactant. So 9.0 grams of H2O times the molar mass of H2O and then we use that mole to mole ratio. Two moles of, oh, I'm sorry. Got a little ahead of myself. That's going to be 2 moles of H2O for every 2 moles of FeOH2. So we multiply this through and we get 0.50 moles of FeOH2. So again, it's asking what's the limiting reactant. So which reactant produced less? 0.13 moles is less than 0.50 moles, which means that, I'm going to write it at the top of the slide so we can utilize our space. Iron is limiting, which means that H2O is excess. All right, so the next thing we're going to talk about is the percent yield. When a balanced chemical equation is used to calculate the amount of product that will form during a reaction, the calculated value represents the theoretical yield, or what you should get if the reaction goes 100% correctly. The theoretical yield is the maximum amount of product that could be formed from given amounts of reactants. The amount of product that actually forms when the reaction is carried out in the lab is called the actual yield. So think about that baking soda lab that we just done. The actual yield is what you measured at the end of the lab, and the theoretical yield is what you calculated you should get. So the percent yield is the ratio of the actual yield to the theoretical yield expressed as a percent. So the percent yield is actual over theoretical times 100%. Because the actual yield of a chemical reaction is often less than the theoretical yield, the percent yield is often less than 100%. Many factors can cause percent yields to be less than 100%. Reactions do not always go to completion. When a reaction is incomplete, less than the calculated amount of product is formed. Impure reactants and competing side reactions may cause unwanted products to form. Actual yield can be lowered than theoretical yield due to a loss of product during filtration or transferring between containers, which we saw when we did that copper lab a couple weeks ago. And if reactants or products have not been carefully measured, a percent yield of 100% is unlikely. So now we can calculate the theoretical yield. So what's the theoretical yield of calcium oxide if 24.8 grams of calcium carbonate is heated? So this is just our typical stoich problem. We're starting with 24.8 grams of calcium carbonate. And we want to see how many grams of CaO should be produced. So we're going to start with the molar mass of calcium carbonate. Use that mole to mole ratio. So 1 mole of calcium carbonate for every 1 mole of calcium oxide. And then last but not least, we're going to use that molar mass of calcium oxide. And when we multiply all of this through, our theoretical yield is 13.9 grams of CaO. So remember, this is what we should get if the reaction goes smoothly and there are no errors. That is what we should get. That is a theoretical yield. So what is the percent yield? So this question is telling us that when we ran the reaction, we only obtained 13.1 grams of calcium oxide. So we know that that formula that we wrote down a few slides ago is the actual yield, so 13.1 grams of CaO, divided by the theoretical, which we just calculated, times 100%, and that is 94.2%. So that is our percent yield. In review, in a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of product that forms, and the percent yield is a measure of the efficiency of a reaction performed in the lab. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a good rest of your day, guys.